Claude is just like the very cute in the corner, shy, you know? And then it codes the whole website in like 3 seconds.
Well, hello and welcome to Keep It Simple with Bro. Today we're keeping it so simple that I'm going to be staring into my own flashlight half the time.
Stare into it. Yes,
I've got glasses on, it doesn't count. So today, Rafa has been glazing his fiber optic internet.
I've been glazing, but now deglazing.
And recently he is not as happy. And we're going to talk about what in the world fiber optics even are.
Where are they?
Ralph gave a great example of what a fiber optic is. It was actually the perfect example for how signal, like what signal is.
Mm-hmm. Fiber optic is like a tube, a hollow tube, and you put a ball on one side, and the ball comes out the other side.
There you go.
That's fiber optic. Thanks for watching, guys.
So, fantastic way of describing data transfer, basically, where if there is ball, that is 1. No ball, 0. Congratulations, you now have data. You understand how signals work.
Mm-hmm.
Now, when you're using an electrical wire, they call it a conductor. We are recording in 3, 2, 1. My bad. When you're using a conductor, that is an electrical wire, right? It is just made of copper, aluminum, whatever your heart desires. That's basically the whole thing. There's either power through it or no power through it. There's either a ball or no ball.
No balls.
And that's how they do every single one of those. Can send 1 ball at a time, basically. So the way they transfer data is if like there's either power going through it for that millisecond or there's none, or microsecond, or even faster in some cases. And so the difference between that and fiber optics is that fiber optics relies on light. So there's either light shining through it. Sorry if that was really bad for the camera. Or there's no light shining through it.
Yeah. Light's a little bit faster.
Light is a tiny bit faster. There's like this measurement that like scientists and nerds like to count. The speed of light. They like to brag that it's like the fastest thing in the universe.
Yeah, but has light ever beat your M4?
I've never raced light, so we're gonna have to see. Catch us next time on the track. But
I'm there with a laser at the track. 3, 2.
We're doing it underwater so we can see the light refract.
Or with the slow-mo guys.
We are the slow-mo guys.
We're waiting to team up with them.
It's just like 4 milliseconds of me trying to like let my brake off, and then the light's already on the other side. But back to the actual topic. But fiber optics are using light to do that. And light is very flexible. And we'll talk about that soon. But because this channel is on the cutting edge of technology, we've said that a bajillion times, we asked ChatGPT to make us a presentation.
The cutting edge of technology. This is, again, the highest point of technology humanity has ever reached.
By far.
And I haven't seen this PowerPoint, but I'm sure it's wonderful.
It took it only 35 minutes to make. And I'm not going to brag, but I feel like I could have done a better job in 35 minutes.
Or in 3 minutes.
But I don't know, 3 minutes would have been hard to mock it all up. But it's dated August 5th somehow. It's a little bit in the future, but
yeah, it's fine.
Can't knock it, you know?
That's
it was optimistic about when you are going to be watching this podcast episode.
Tomorrow. I already knew.
So yeah, fiber optics. We're going to talk about the past, the present, and the future. We're going to go into a little bit of the history of it, the modes of fiber that are present, the applications it's used in, and like what's happening in the future of it. You know, what is going to be the difference in fiber optics for our lives, and maybe what ends others' lives.
And I just like that artistic choice that it made in the first slide.
See, it's a true journey of light.
No, in the first slide.
Oh, this?
Yeah, where it put the text over the other text. It's artistic, you know?
It is. It really highlights the idea that light can be anything and it can be multiple things at once.
Exactly. ChatGPT is a genius, bro.
So, as you said, our outline today is looking very thick. Explore the journey of light. See, that's a light strip.
Yeah, we'll zoom in. We'll zoom in on that part. You guys don't see that.
So there's going to be... we don't care about this part. So the history.
This is a beautiful graph. Timeline.
This is actually not starting soon enough because fiber optics, or at least the idea of using light to transmit signals, actually started in the 1800s, where these beautiful French gentlemen were like, hey, you know, if we shine light at each other from really far away and we concentrate that light, we can say yes or no. And they use that for essentially Morse code. And if there's a light, yes. If there's no light, no.
So that's transferring data.
Transferring data, brother. Already there, from like the early late 1700s.
So they had 1 gigabyte fiber internet in the 1800s?
It depends. How fast do you think people can do tap, 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 tap?
Some of the good ones can do it fast.
Yeah, a whole half gigabit per year. So, and then in like the mid 1800s, another French gentleman, and I think half an American guy, like in the 1850s, 60s, they were like, hey, what if, or they observed that light passing through water refracts, which means it goes like, so it changes path, changes course, and it follows the light, the path of the water. So they did a lot of experiments where they were like, basically they got a hose, and they were like pointing the hose forward, and you know how water would go out and go down a little?
Yeah.
If you shine light into that, like a laser pointer through it,
the light would
at
also
just
follow.
the right angle, the light blinks
Awesome.
off and goes down.
That's awesome.
It doesn't pierce. And they were like, whoa, this is going to be so cool when we have Morse code part 2.
And then they made Spectrum.
Then, yeah, we're getting there. Spectrum doesn't have fiber yet, but yeah, or at least nearby. So they got all that stuff, and they were like, this is sick. So then once we started being able to extrude glass and like make wires out of glass, then that technology went insane.
Yeah.
And that's kind of exactly what happens through all of human technology, where like somebody has an idea, and then over the next few centuries, somebody like else was born. They go crazy with it. Small step, small step, small step. Oh, we're actually on the moon now. Okay.
Yeah.
So in the mid 1950s, as we have noted here, there was image transmission via fiber bundles. Cladding concept. Cladding, we'll get into that soon once we get into our next topic. But then in 1961, they actually were able to prove this guy's idea with light boinging around through water.
Yeah.
They finally did it through glass fibers. And a fiber is just like a strand. So like your hair would be a fiber, basically.
Yeah.
Technically, no? But yeah.
So fiber optic is still glass, technically?
It is glass.
Yeah.
It's light through glass. That's literally what it is. And then a few years later, they actually figured out how to use pure glass and cladding around it to reduce loss, which we'll get into soon. I promise. ChatGPT wasn't very good at keeping with the story. I don't know why we're doing the history first instead of what the heck
It did a great job.
And then we got lower loss fibers. So we were doing 20 decibels per kilometer. We'll get into that too, I promise.
He's promising everything.
And then in 1977, the first commercial fiber optic communication trail was born.
Now that's interesting. Where was that?
I don't know. That's what I'm saying. ChatGPT didn't do a good job with this presentation. And I'll give you guys some of my own understanding because I do work at a place that does a lot of work with fiber optics. I don't do fiber optics at that place, but I did get a presentation by someone who has a doctorate in quantum physics about this topic. So I'm basically a quantum physicist.
You should have been handed a degree as well.
I should have. But yeah, today, 76 million homes.
That's outrageous.
Are able to have fiber optics.
76 million.
Yeah.
And somehow neither of those are both of our houses.
Yeah.
Makes sense.
Guys.
Well, we're in a small town.
Yeah, nobody really lives around here. We're like secluded in the middle of Nebraska. So we're just jumping right into it. Okay. So this is kind of what you would see as the, what do you call that? As the basic makeup of a fiber optic. I'm so happy that it went with a French
envelope opaque.
Yeah. So the way these fiber optics work is that there's a center. It's made of pure glass, essentially. And it is going to be what is carrying that light current, basically.
Mm-hmm. The information.
Mm-hmm. And that is supposed to be like no loss as much as we can. Slightly going out from that core is still kind of glass, but that is a controlled, let's call it like dimness, basically. And that is your cladding. And that cladding essentially gives you somewhere for the light to refract from, like to bend, and then go back to the center. So
like a funnel, almost.
Sure.
No, like keeping it inside, keeping it in the middle.
It is, yeah. So it's like ping pong between the walls.
Yeah.
And then what it eventually does is now you have a wave going through that wall.
Mm-hmm.
And when you have something like multimodal as your source, it means that there's multiple waves of light and they're just bouncing around with each other.
Ooh, very nice.
The only disadvantage with that is the further you go out, kind of worse your signal gets, because whenever you have multiple different light sources, now it's like they might be mixing with each other and getting in each other's ways. If you have in the same color, we'll get into that. So there are two versions of this core. There's a core for single mode fiber optics, which means there's only one ray of light shining through it. And there are cores for multi-mode, which was what I just explained, where there's multiple different like rays of light essentially.
Does that just mean more information?
No, there's all essentially both the same information. It's just different ways of doing it.
Okay.
And you might be like, okay, if like they're the same thing, then why do they exist? Well, technology advances step by step, and first we had multi-mode, because those are 50 microns thick.
Small.
A micron is 1/9 of something. A micro is, never mind, 1/610 with 6 zeros at the bottom. So 1/1,000,000th of something.
What's something?
Of 1. So whenever you have micro, it's 1/1,000,000th. And this is 1/1,000,000th of a meter.
Of a meter. That's what I'm saying. You said of something.
So 1/1000th of a millimeter. So if you know what a millimeter is, count that into 1,000 pieces. That's right. You'll never get there.
You can try.
And so whenever we're working with electrical wires, essentially, we're working with millimeters.
Okay.
So like if you have like a 24 gauge wire, that is 24 over 30 seconds of a millimeter. Of an inch. My bad. And those
top-notch information.
Top-notch. And those what do you call that? And those measurements are done in like millimeters, essentially, when you go overseas to the rest of the world.
Yeah.
But when you're using fiber optics, you need to be like airtight. Because when you're doing single mode, you're at 9 microns, between 5 to 9 microns, thick of that little glass core in the center.
Yeah.
That is enough just for one ray of light, essentially, to be going through it.
That's insane.
Basically, we're the masters of the universe, because we can control a single ray of light on its own. Like
through glass. No one's thought of this before. Not even the Egyptians?
Not even God, apparently. But like
he was waiting to release that information.
Not even the Egyptians.
For the pyramids, you know. Maybe that's how they used to make the pyramids.
That's what
fiber optic cables.
Yeah, they lifted them up with glass strands. But when you get to this level of like detail, it gets so expensive. So getting to like that single mode 9 micron wire, terminite, cable, wire is what we're gonna call it, even though it's not a wire, is incredibly expensive compared to doing that 50 micron, because that's 1/5 of the size, and that is a bajillion more parts that you're gonna have to throw away that don't meet your specifications.
So that was like the first version?
These are currently what we have.
Oh, okay.
We have single mode and multi-mode.
Okay.
Yeah.
What do most internets use?
Most internets, depending on where you're going. So if you are going across Google, AT&T, I guess, all the big guys, whenever you are using internet, you kind of have to go across the universe, the world sometimes, right?
Yeah.
So how do we like call our relatives in like, let's say, Armenia? We definitely don't have relatives there.
Yeah.
But like whenever you need to talk to them, how does the internet get from one side to the other? Is it Wi-Fi the entire time? Not how that works.
Fiber.
Fiber, that's right. So fiber is laid on in thick bundles all the way across the seafloor to get from one continent to the other. And then there's more fiber underground going straight across the continent to get to every country in the world, essentially. Or at least that's what it was until we had things like Starlink come up.
Yeah.
Which kind of use
Satellite.
LEO satellites, so low Earth orbit satellites, to communicate data.
Also sick.
Oh, very sick.
Thanks, Iran.
Shout out to him. I don't know if we can have him in the podcast anymore. The people seem to be shutting down podcasts because of him. But more importantly, he's doing cool stuff.
I'll still invite
New
him.
cool stuff.
We'll still bring him on.
The X notification's still out there, so he hasn't responded yet.
Oh, okay.
But
hey, any kind of publicity is a good publicity.
Sure.
So
we'll get at least one follower from that. But so yeah, whenever you're doing these like massive bundles of cables, they're using single mode cables, because a single mode glass strand, you can send across 60 miles of data. For comparison, you could do like maybe 10 kilometers, so around 6 miles if you're using 6.2 miles if you're using copper. I think 6.2 miles might have been the multimodal. It would have been cool if ChatGPT would have given us. Never mind, it does. Here's the comparison of the two. Shout out to him. So these lasers have basically unlimited bandwidth across higher distances. It says above 10 kilometers, but its limit is 60. It's 100 kilometers so far. So what they do underwater is they set up these massive bundles, and then in comes good old reliable copper cable that has to power kind of adapters that resend that light signal.
Yeah.
So every 100 kilometers, probably less, they resend that same light signal in order to like keep it going.
Yeah, like redstone.
What?
Like redstone rails in Minecraft.
Yeah, you got to repower this.
Tell me that was a good example, bro.
Great example, yeah. You like lose steam while you're going.
Yeah.
But
it's the first thing that came to my mind.
That was a great thing to bring up, yeah. So, but whenever you go to multi-mode, your max is like half a mile.
That's very little.
Half a kilometer.
So you would have much more of those resending things.
Yeah, you'd have to do much more resending. But that's why they do multi-mode, single mode instead of multi-mode.
Yeah.
But like, let's say you're in like a fighter jet, allegedly. You don't have to go that far of a distance. So you don't really need to be using single mode if you're on a single aircraft, essentially.
Okay, I see.
Or if you're on an aircraft carrier, you need to send data from like the bridge all the way to the tip of like with a radar sensor. That's probably less than half a mile.
Yeah.
I don't really know how long they are, but I'm guessing less than half a mile. But so in that kind of scenario, you can afford to use multi-mode because you're not really losing out on the bandwidth. It's still about the same speeds. You're going to be fine.
Mm.
Plus, you're saving money.
Always a great thing here.
And a really big problem with using fiber optics is that it's just a strand of glass still. And if you ever had glasses of any kind, you know glasses get dirty very easily. Now, if you have even a speck of dust on something that's smaller than a speck of dust,
yeah,
you kind of lose all use of that.
Starts clogging the pipes.
Yeah, and then you'd have no signal going through.
But how would you get dust on it if it's super enclosed and it's protected?
Well, so in those kind of cases scenarios, they have like FOD encapsulated chambers that nobody can bring like air into or something.
Yeah.
They have like clean rooms that are super expensive to maintain and to have. And you need to be operating them in the right environment. But sometimes you need to be transferring data from your fighter jet in order to your ship, right?
Yeah.
So you have to have a connector that connects into that fighter jet to get the signal connected.
Mm-hmm.
You need to have that connector in a place where you can properly service it. So they sell kits that are super expensive to wash these little tiny fiber optic termini because at the end of each cable, like let's say you need to connect two systems together, right?
Yeah.
It's just glass touching tips. And they're lined up at the level of microns. Wherever like
that sounds crazy.
Two wires just coming like this. And the tolerances for those things are stupid.
I'm sure. It's glass.
It's
and light.
At 9 micron.
Yeah.
I don't know how to show you 9 microns because that's like way less than your hair.
Yeah, it is.
So yeah, crazy stuff. Something to mention too is that this light, it's not moving at the speed of light, sadly. It's only moving at like 60%. So around 200,000 kilometers per second.
That's not that fast.
It would take it a whole 12 minutes to reach the sun from here.
What?
Wasting our time.
Your 0 to 60 is way faster than that. That's
yeah, but quarter
crazy.
miles like 12 seconds. So yeah, those are the two different kinds and what they're kind of used for, or two different kinds and what they differ.
Knowledge gained.
Knowledge gained.
So the one we have in our houses are single mode.
That's hard to say. The ones that you have for Ethernet are usually single mode. Yeah. That's why it's so expensive to get going, and most companies don't even have that up yet, even though this technology has been around since the 60s.
Is it fragile?
The wires?
Yeah.
Yes, actually.
So if I get my wire in it,
no, they are bendy.
but are they foldable?
You can't pinch them.
That's what I'm saying.
You can. We don't really have a good example. We do indeed have. Excuse me, sir.
Oh.
We have this wire. Hopefully, you can see it clearly. You can do like this.
Yeah, I
to
get
fiber
that.
optic cable.
Well, it is. Obviously.
No, I mean the fiber optic cable. You can do this to a fiber optic cable as well.
That imagine.
But if you do this,
don't
if you squish it like that, it's not going to go well. For a typical one. For your Wi-Fi, probably it's not going to go well.
Yeah.
But if you are in the aerospace industry and you're like, hey, give me good stuff, people are going to give you good stuff. Like, I don't want to give away too many spoilers, even though
there's
it's public
cool stuff
on the website. But we have fiber optic cables that you can tie.
Oh, nice.
It's kind of crazy.
You're
not supposed to tie them, but it's like a little.
It's a good demonstration.
It's a great demonstration.
You're towing a tank as you're sending information into it.
Easy. But yeah, so these multi-mode, single modes, they're basically the same size, the whole cable, as a regular copper wire would be. Because on top of this glass center, little thicker core outside, and then on the outside of it, you have a little envelope. Is just something that encapsulates it, goes around it entirely. That is not going to let the glass penetrate at all.
Yeah.
So no outside light.
I mean the light penetrate.
Yeah. No outside light, no inside light going out. And then around that, they have something to protect this, because it's essentially the same thing as a copper wire. You need to have kind of like a shielding on it to protect it from the twisting, bending, and stuff, and pulling. And then on top of that, you need to have environmental protection, which
makes
is
sense. Mm-hmm. Obviously, you got to put many layers of protection around this.
That's right.
Very
Undershirt,
delicate.
Jacket, nipple.
The nipples are protected.
It has to be the protected core.
Yeah.
So just like regular wires you'd see for copper, it's got shielding, it's got jacketing around it to make it safe, to make it happy. But that makes it thick. Something that...
Thick boy?
Thick boy. Something that ChatGPT is not going to mention just because it's really new tech. MT fiber.
Super new tech. ChatGPT barely can do anything.
I was about to put Glendale. All right, this company.
What's this company?
So these things called MT Furals, this is military grade stuff. This is literally aerospace grade, military grade stuff. Literally. This is above anyone's pay grade to buy just for the vibes.
We'll buy a foot for the pod.
Maybe we might be able to pull that off. So this stuff,
if you pull some fibers,
so this stuff is really cool because if you see right here, it's gonna be hard to. Thank you. I'm glad we were getting all this information.
Maybe go back a little bit.
No, I refuse.
Okay.
This is the one I want. Okay. So all of these little colorful strands that you see right here
are all light.
Are each a single node termini. Mm-hmm. So a single line of fiber optic going through. And they can have 2 stacks of 16 on top of each other. So now you have 32 different fiber optic lines going through something that's smaller than my pinky. They could put 18 of those in a single connector. And the connector is this thick, and you have 18 pinkies in it. That is so much data. That's insane to comprehend.
Now that's what I want in my house.
That's what you're basically going to be getting.
That's what I want.
If you go into Lockheed Martin and you're looking in their fiber optics department, this is the stuff they would be using.
Wow.
That is the top of the top. and it is top of the top dollar to use.
I'm sure. Well, obviously, you're getting the best of the best. Gotta pay the price.
Yep. So you might be like, why don't we already use this kind of stuff? Why don't we use MT Furals and stuff? Because
It's expensive.
the problem isn't just the lines that run through. Those are expensive, but they're not like crazy expensive. It's like 3 to 4 times more expensive than copper. Whatever. That's not that bad.
Easy.
The problem comes when you have to read all of this data that's being sent over because it's so dense.
So you need like a powerful receiver.
You need something. I don't know. I don't think Glenair has it on their website anymore just because it's
They don't sell it.
fiber optic MT reader, I think it would be called.
That's funny. That the problem becomes that you're getting too much information. Now.
Yeah, you cannot. You can't affordably read it fast enough because you need none of these guys. It is some kind of like little board mounted thing that you put on your PC. Oh, this one looks like it. No, not really. But it is some kind of thing that you put. Oh, there it is. There's the boy. This is for a single node, just basic stuff. LEDs. But what it is something that you mount on a PCB, and it needs to be able to read all 32 from every single one of those nodes, or every single one of those little contacts. And that gets stupidly expensive. So if you buy like 150 of them, maybe it'll be like $40,000 per.
That's kind of insane.
Yeah. And that's why we don't have it at home yet.
Yet.
But they're not working on it, I promise you that. They're not trying to help the consumer just yet.
Oh my goodness, I'm stuck with only 5 gigs.
Gigabits.
Oh, that's only 625 megabytes, bro.
Shout out to Ruffles Mac.
Yeah, not shout out to any of the liars at internet companies.
That's right.
Sorry.
Even though they tell you 1 gigabit Ethernet, it means
Oh,
1/8 of the gigabyte.
What does everyone think? Oh, they're giving me 1 gigabyte.
Yeah, because that's how we measure storage. Yeah, it's a funny little computer thing that everyone are.
We're all getting lied.
Yeah, you're.
We have to stand up for this.
I stand with Raw.
I stand with Frontier.
I do not stand with Frontier. I don't know who that is. Now, where are these being used?
Currently with AT&T. Sorry, just shut up.
It is. He's been glazing in AT&T until today.
Yeah.
Now he's mad at him.
Yeah. Mad at everyone. Mad at you too, buddy.
He's trying to get 1 gigabyte Ethernet per second. Or 1 gigabyte per second.
How much is that, bro? Go back to the Glenair thing. Order me a couple.
There's no one that can read it fast enough. AT&T can't transmit you this data to your house yet.
Oh, yeah. Right. That's just a wire.
Yeah, the wires can do it. Like, the hardware's there. It's just getting that level of communication silly. But this is like a little off topic. But there's this thing that they're working on called terabit Ethernet.
Terabit?
Terabit.
So like terabyte.
Yeah.
So like the next, so 1,000.
1,000 gigabits. And they're currently at
AT&T
400 gigabit per second Ethernet.
Who?
Just society.
Where on earth is there the fastest internet?
USA,
like, of course,
baby.
it's gonna be those. No, I don't mean like that. Like, it's gonna be one of those crazy companies, like Northrop Grumman or something. I just wonder
Actually,
what internet.
I don't think Northrop is in the list of people who are actually looking for this kind of.
Not looking, but like, or Glenair. Do they have like crazy internet?
At the company?
Yeah.
Oh.
So who has this?
No one has this. This is like the cutting edge of technology right now.
Okay, like 10 years. Whatever.
Yeah. So they call anything terabit Ethernet anything that's above 100 gigabits currently. And 400 gigabits is currently the standard.
That's pretty awesome. That's up there. So how many gigabytes is that?
200. No, I'm dumb. 50 gigabytes per second. Yeah.
That's not even that crazy.
Are you joking? With this kind of Ethernet, you'd only take like 32 years to download all of Wikipedia.
That's a long time.
It is. No, all of the knowledge of the human race actually is what the quote was. We can actually ask ChatGPT.
How fast can you download GTA 6 with 1 terabyte internet? So you're saying it's 50 gigs per second, gigabytes.
Hmm.
GTA 6 would be like probably 2 terabytes.
Okay, GTA 5 is about 100 gigabytes. Gigabytes, yeah. I don't know about that. I feel like it's more. But
It's definitely
1
more.
terabyte per second is 125 gigabits per second.
So it would take 0.8 seconds.
Yeah.
I mean, if I had that, I'll just download delete just for fun. Just be like, wow, wow, wow. Yeah.
But then the problem becomes what hardware can read fast enough for that? SSDs can't get into that kind of speeds. Let's actually ask that.
Technology sucks right now.
It really does.
I thought stuff was faster.
Fastest SSD read speed.
What is that in like hertz?
No, it's also going to be in gigabits per second. Megabits per second. So Samsung has one that's 13,000 megabits per second. We're a little bit behind in technology.
How much do we have to be at?
We got to just be at, where was it?
125 billion?
125 gigabits per second. We'll get there soon. Oh my god, 125 million bytes?
That's why. Go down? What was the fastest?
That's 125 billion?
That's what I'm saying.
I forgot what giga even meant, if I'm being honest. I thought it was just a number.
It just means a big guy.
Yeah, but fastest consumer grade SSDs as of today is 14 megabytes per
Hey,
second.
Corsair.
That's actually awesome. I do need new memory. Or new
Get
SSD.
this, please.
I can't.
I don't know for what.
I already have the Samsung one that's up there.
Samsung. That's so slow, though.
Oh, a whole 1,000 megabytes per second. What am I going to do? But, yeah. So the thing is that, like, fiber optics are quick. And there's a bajillion things you can do with them. But it's hard for everything.
You need the rest
to
of
keep
the
up
technology.
together. Yeah. It has to work as a full system. All right, back to our presentation.
Fiber optic SSDs.
That's the thing. They can do it. But then it won't work with the rest of your computer.
Fiber optic power supply.
That one I don't think they can.
Fiber optic case. The case itself receives the
It's
data.
It's a bubble.
When I delete this part, guys, we're making.
So, okay. Where is it currently used? Fiber optics.
Where is it currently?
Communications. Your internet service provider. It's the backbone of their communications. So even Spectrum, when they say they can't give you fiber internet, they themselves are getting internet through fiber optic wires. They just can't get it to your house.
Losers.
Yeah, they have to be using copper wire still.
Sucks.
And whenever you see like broadcasting, streaming and stuff, like for TVs, also using fiber optics because that's how they get it to their main system, I guess.
I'm sure they need a lot of speed. Obviously.
They do be. They're broadcasting it to the entire like world sometimes the U.S. Healthcare, apparently endoscopy and imaging.
Those cameras, right?
Which ones?
Like endoscopy. Isn't that thing with the small, really
Inside
small
human
cameras?
beings? Yes.
They make that sound when they go in.
That's what Garo does. He goes inside.
Shout out to Garo.
No, dude, that's disgusting. I hate it.
Garo?
I hate him for doing that job. It makes me upset. But
that's with fiber optics.
With fiber optics.
That's pretty cool.
It's literally just. Actually, I don't really know how it works, but it is basically just a glass tube.
Yeah. That's what fiber optics is.
Yeah, that's actually, yeah, you're right. I know exactly what it is.
Tube. Laser surgery. That's interesting.
I don't know about that one, but okay. Industry and defense. Secure. Oh, you know what my favorite application of fiber optics is?
The Iron Dome.
No, we don't support that with fiber optics. It's with copper.
Oh.
So whenever you are in a military base, let's say you're in like Edwards Air Force Base, nearest military base, they need to have a clear line of communication with the White House at all times. Because we can't have somebody like EMP us from above, and then now the military can't.
My internet's down.
Mr. President, I can't call. I'm on TikTok. So they need to have secure, untraceable communication lines that nobody can like interfere with.
Yeah.
So what they do, don't tell the Chinese government, is they dig really deep underground and lay these fiber optic lines between allegedly, all of the military all of the military bases. And that way,
Is this public knowledge?
Yes, it is public.
Okay, thank you.
I'm just joking around. It's like speculative public knowledge. I haven't been told anything from like.
I haven't dug. I haven't dug to find
And no one can. Actually, they did say they did it in Iraq.
What? They found fiber optic.
No, to use those fiber optics. Like whenever they were setting up bases in order to have clear communications from one outpost to another.
From Iraq to U.S.?
No, brother.
Oh.
From Iraq to the other outpost in there. I'm sure that also used fiber optics in some ways because it's still using the internet.
But okay, yeah.
So, yeah, because there's untraceable. There's no EMI coming, electromagnetic radiation coming from it.
Mm-hmm.
There's no electric signal that's creating heat or anything.
Yeah.
It's just homie light just doing what he does.
Meow.
Yeah.
That's pretty awesome.
It's pretty sick. And that's like my favorite thing that they use.
So is the speculative thing that it's in every army base is just interconnected to the White House?
Speculative, bro. They're probably doing it.
I mean, it makes
it's
sense.
The latest tech. Who else is it going to be for? I don't know if I can say that, but yeah. I know Joe Rogan can say it with like happiness and nobody will care.
Yeah.
Because he's
Joe Rogan. Yeah. I bet Joe Rogan has a fiber optic cable connected to the White House as well. From his house.
To Trump, definitely, bro.
The main phone on Trump's table is Joe Rogan.
The big red button is to call Joe Rogan. It airdrops him directly into the
into the podcast.
Remote learning research. They do fiber optic research. I don't really know what it's trying to say. Low latency trading and data centers.
Oh, trading? Like
crypto trading. For their
fiber optic crypto trading, the new trend.
All right, cost and benefit analysis, Rob. Why would you use single mode instead of multi-mode? We've already talked about this.
It's
what?
Cheaper?
Yeah, single mode's more expensive, yeah.
Oh.
But multi-mode is cheaper. It's easier to install because it's thicker wires. You don't have to worry about it.
Yeah.
And it does not cost as much to read the signal.
Interesting.
Another really cute thing that I'd like to talk about that isn't here for some reason is light travels in different wavelengths, essentially. So you could speed it up, slow it down, make it blue, make it red, make it yellow. It doesn't care.
Yeah.
It's going to have a different frequency, essentially, whenever it reaches the other side. So with that, now this one line of fiber optic, can now send 16 different signals in one go. So every one is 16 different times in 16 different channels. So the reader over there is now getting 16 different messages in one instance of data receiving.
That's a lot.
That is. And they don't interfere with each other because now they're moving at different wavelengths. And so that's kind of insane.
That's pretty cool.
Yeah.
We're just taking like different colors.
Yeah, literally. It's just different colors of light. So if you look inside of one of the transceivers, which is the stuff that a transceiver receives and sends and transmits information at the same time. Those are really expensive.
That sounds really cool.
It is really cool. That's the thing that I was telling you. It costs like $40,000 if you're buying 150 of them.
That's a good price in bundle.
Yeah, right. But if you have just like a receiver where it's only like receiving data from one side, and then next to it you have a transmitter which is sending information.
Yeah.
You know, if you look at our mics, they actually say transmitter because these are the ones that send signal to the other one.
Another one's receiving.
Exactly, it's a receiver. So yeah, it's like one-way communication, but transceivers are both-way communication. So you save on space, but do not save any money.
So what's the point? Just the space?
Of what?
The transceiver.
Yeah, so in some scenarios, sometimes you want to be able to use the same wire to do both jobs.
Makes sense.
Because you don't want to run multiple wires through for the same thing, you know?
Yeah. At that same time as it's receiving through the same
send
wire.
messages. Yep.
That's pretty cool.
And not just same wire, sorry. Same gang of like 16 wires.
Yeah.
Because it's still using that one contact if they're using MT Furals. Fural is a dude's name, by the way.
Shout out to Fural.
Yeah. So now the future of fiber optics. Let's see what ChatGPT
Where are we going
thinks.
with this?
You know, smart deployment in AI. I agree. I don't know what's going on in the bottom over there, but okay.
I like that graph. Makes perfectly no sense. Actually, no. It's saying 2024.
Oh, the percentage of households.
Yeah,
that
so
are
it's like
serviceable.
right above 50% that there's fiber, And then 2028, in 3 years, it's like around 75%.
Yep.
Let's see if we're in that 75%.
I really hope so. They made us a promise that we'll eventually get fiber optic. We'll see. So the smart deployment in AI, that's definitely going to see a space that can get some massive boosts from using fiber optics.
Of course, to
because
receive
AI,
more knowledge.
AI is unlimited thinking, assuming that you have a really good GPU or a good house of GPUs. And the faster you can get that information across, the faster they can work through it.
Yeah.
Because I think
it'll get smarter.
It will definitely get smarter. It'll definitely be able to think faster.
Yeah. Think
more things and communicate with itself. So, another thing that's holding technology back right now is the actual communication of data. Even though we were saying 400 gigabits per second, still not enough for computers.
That's what I'm saying.
Because NVIDIA's got those racks of their newest crazy GPUs that are made for AI, and it's these are sending 5 trillion bits of data every second. It's we have nothing that can send.
See? So I'm saying, bro, it's not enough. That 1 terabyte's not even enough.
It's not. The future's coming eventually. And with AI getting faster speaking, they'll have faster brains, faster learning, faster development. So we'll have more specialized AI that are at the same level of our general AIs. Multi-core versus hollow core.
Like a hollow point.
For each multi-cores and air cores boost capacity. Oh, okay, that's what we were just talking about. The multi-core would have been, I believe, what it's trying to refer to is the empty field we just looked at.
Yeah.
Where it's
multiple
each
layers.
Contact has multiple of them.
Yeah.
5G convergence and fiber carriers invest heavily. They do be. They're putting a lot of money to compete with each other. AT&T is literally sending people to other people's houses to be hey, you don't have fiber, but we'll give you 2. And I was okay.
And $20 Visa gift card.
Multiple times for some reason. But yeah.
Quantum merging apps.
Ooh,
quantum computing. Love quantum computing.
We forgot to talk about quantum computing. We definitely just didn't have any idea how any of it works.
I do. It's like computing. Quantum.
There's no way.
I'm telling you. I have one now. Order from Amazon. Order from Temu.
Temu quantum computer. It can do a whole 1 calculation per second.
Labor shortages and BEAD program drive training and public-private partnerships. I love private partnerships.
I don't know what that means, but private partnerships are pretty sick.
They make the world go round.
Conclusions and takeaways, Ralph. What did we learn today?
We learned that fiber optics have evolved from experimental image guides to a universal communications backbone over 7 decades. As in, they came a big way since when they started. Now that's what we rely on. The structure is slender core surrounded by cladding. We learned what cladding was, right? Enables light pulses to travel long distances with minimal loss. So there is no, horsepower loss. Single mode versus multi-mode. Choose based on distance, bandwidth, and budget. High reach versus short reach economy. Interesting
indeed. I can't comment on that. I don't know what it's trying to say.
I know. That's why I stopped reading. But at the end of it, the most important words. Thank you.
Wow. And then at the bottom, they have links. What? But yeah. What did you think of that presentation from ChatGPT?
I think it was very impressive.
Did you think it was a good starting point?
I think it was great. They put images in, and it all made sense.
It was actually instructed to pull relative images and post it into every slide.
There was one picture.
There was one relative picture.
It sucked.
It was really... I mean, it looked interesting. The presentation sucked, but bad.
Sucked butt. You're right.
Sucked butt as well.
Claude would have made it better.
Thank you for watching. That was the whole episode.
Yeah, we got to give a shout out to ChatGPT. He made that whole slide. That's why it looked that amazing.
It was great talking to you all about fiber optics. Hopefully we can have fiber optics so you can watch our episodes faster.
Max speed, highest quality.
You should do that. I'm sure.
Let us know in the comments if you have fiber optic.
Let us know in the comments if you care about having fiber optic.
Let us know in the comments why Spectrum is a loser.
We're sponsored by them. They're not going to let me upload